Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graph transformations. This is standard A.3E in the great state of Texas, and we are using item number 45 of the 2017 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have two graphs here, g of x equals x, and then g of x equals f of x plus 3. That's the one graph. And then we have just the basic f of x equals x. Same coordinate grid. So which statement describes how the graphs of f and g are related? All right, well, so let's just draw a large coordinate grid here. And we can at least try to plot what we think some of these might be. And so I'll just put some of these points here. And for the most part, we'll probably just kind of hang out in the first quadrant there. And then we can extend anything over into quadrants 2, 3, or 4 as needed. So let's look at this first one. F of x equals x. What kind of graph is that going to be? Remember, our x is going to be our domain. So this is going to be our range. So if you want, you can think of that as a y, if that helps you a little bit better. So y equals x. So if we want to plot some points, right, that's going to be pretty simple. 1, 1, 2, 2. We are also going to go through the origins. Let's bring that back. So it looks like it's going to be a line that just kind of diagonally bisects the x and the y axis. So the points are equidistant 1, 1, 2, 2, 3, 3, 4, 4. All right, so that's probably one of our most basic functions out there. F of x equals x. Now what about the second one? G of x equals f of x equals plus 3 here. Well, if f of x equals x, then we can actually just substitute in this x, and we can say g of x, if it helps us, equals x plus 3. Since f of x equals x, we can substitute in one for the other. So really, we're just going to take our x, right, and then we're just going to add 3 for the y. So let's start with 0 up here, and that's going to be 3. 1 is going to be 4. 2 is 5. 3 is 6. So we can plot some of these points here. And let's see, obviously we've got a y-intercept now that is not going through the origin. So there's my 0, 3. There's my 1, 4. There's my 2, 5. There's my 3, 6. So you know what it looks like? It looks like we're going to get a parallel line here. As much as I can draw it right here. The only thing is I just moved it up. So this is my g of x equals, and then I'll put the original here for reference, f of x plus 3. All right, so now we have a nice visual. You just took the original and you shifted it up. Okay? So let's see what our answers are here. The graph of f is shifted 3 units up to create the graph of g. Well, looks like exactly what we just did here. But let's check out B, C, and D first. The graph of f is steeper. Okay, so when we're talking about steeper or less steep, we see that same thing on D. What that's talking about is that's talking about the slope, right? And the graph is not steeper or less steep because we didn't change the slope, right? The slope for both of these, it's assumed, but it's a 1 right there. It's 1x. That's the change in y over the change in x. So the slope hasn't changed. That would happen if we were to do like g of x equals 3x. Well, now I'm going to make it more steep because I'm going to multiply that by 3. And I didn't shift it down either. So, yep, that's my answer, A.